Hi, this is Futurist Shara Evans, and today I am absolutely delighted to be speaking with a colleague of mine from overseas in Leeds, UK, Professor Robert Richardson, who is in the robotics department at the University of Leeds, and he and his team are working on a project to design teeny weeny little robots that will self-repair cities. Hello and good morning, Rob.
Good morning.
So let's start by talking about this amazing project. As I understand it, it was funded from a grant from the UK government of £4.2 million, and it's to design brand new little tiny weeny robots that will make city repairs something that happens automatically. So let's just start by you giving some background on the project and how you got the funding.
Yeah, so the funding actually was through environmental issues in the main sense. So one of the issues is that you want to do engineering in cities, obviously you need to repair cities, maintain them. But you need to do it with the least environmental impact. That's kind of the overall thrust of the core, if you like, core funding. So our approach is, okay, well, how do we do this? And we were thinking, okay, well, robots are great for this because the potential for robots is to do engineering but with minimal impact. That's really our focus. So we're not really talking about automating huge trucks, huge lorries. It's trying to maintain the city with the least possible environmental impact, personal impact, anything else other kind of impact. So using small robots to try and get in the cities and to inspect them, to find problems and to fix them, say, very sort of small scale before they get big, is really our goal. We often think of it as being like, we call them UK urban foxes. So you would never really see a fox. Sometimes at night time you see a fox occasionally. That's kind of our vision. So these things won't be in your way as you walk down the street, you won't be falling over them. They'll be doing things when you're not about, and when they can get away with it when it's quiet, and you won't notice, it'll just be done. That's our vision. In particular, because we're catching it early, the energy, the resource, the waste, everything is just minimised. So it's better for everyone, really. That's our plan.
So when did this project kick off?
So we started in January, so it's still quite early, and we've been recruiting for a while and things. So we're just starting to ramp up now. So it's a 5-year project. We're starting to ramp up now with people, so it's in Leeds, but also across the UK and the universities. So we've got people in Birmingham, Southampton, and UCL, which is London, who are working on the project led by Leeds. So yeah, it's just really getting ramped up now. And it's getting to the starting point now where we're starting to kind of create these robots and starting to kind of start testing them.
Oh, that sounds so cool. So I want to talk to you about the 3 different modes and find out where you're at in robot design with the 3 different modes that you've envisioned. The first are what I would call flying robots that are able to go up on tall structures and be able to perch like a bird might perch and do some repairs. And I've had a lot of, I guess, mental visions of how these little drones might be with manipulator arms and so on. But tell me, what are you doing in this space?
Yeah, so it's all about, we call it perch and repair. So the traditional thing is perch and stare. So this is when air vehicles land and look at things. We've got to take that stage further now, it's perch and repair. So the whole point is to land somewhere and then manipulate things to repair and to replace things. And it's pretty tough. So if you've got a normal kind of drone, if you like, with rotor blades, it's not so bad because you can hover and you can land on things. But the problem with that, of course, is we all know that drones have very little battery power. They don't last long. So if you're going to fly around a city for a long period of time, it's not going to be a great thing. So we have work already which we can perch on lampposts autonomously. So we have work, actually at the University of Southampton in our consortium, who have got these little drone things automatically landing on lampposts. So they're not, no one's controlling them. They can fly there. They can perceive the lamppost and they can land on it. So it's kind of a first demonstration in that way. We've got some work from the past looking at how we can land fixed-wing aircrafts. And this is tough, of course, because you know that when you've got a fixed-wing aircraft, you can't go slow. If you go slow, you fall out of the sky. You want to slow down a bit, but not too much. And then you want to be able to perceive at quite high speed what you're going to land on, and then have some kind of end effector or legs, whatever it might be, to land on that. So we know how to do it sort of computationally, and we've got lots of nice algorithms. And doing it physically is tough, so that's what we're working on right now. And there's lots of different schools of thought. Some people say you should remove all the energy, so that means that when the aircraft comes in, it would be falling out of the sky. And if you don't catch, you crash. Yeah. I think I take the view that in fact we shouldn't be going quite so slow, so we should always be able to abort. So you should be able to coming in, going slower than you might expect. You've always got enough energy to be able to carry on flying if you fail to land. But of course, the price of that is the fact you're coming in faster, and you've then got to try and remove the energy through some kind of legs or something. So it's quite challenging. And so perception is the biggest challenge, I think, in this domain, because especially when you're coming in fast, to be able to see things clearly is difficult. You can, of course, make things like big, bright orange perches, which make it a bit easier. But even then, it's hard. But if you want to perch, as birds do, on branches or other things, trying to perceive them is really, really tough.
Yeah, and you'd have to have a fair amount of sensors on these robots as well. So, you could rely on things like GPS if you had, a signal to hone into. But if you had GPS drift, then you might have problems, or some other radio interference. So, and of course, the more sensors you put on these little robots, the heavier they become as well. And that would also, I would imagine, impact the ability to perch on things like wires. So what are your thoughts at this stage in terms of the sensors you put on these drones?
Yeah, so we're looking, exactly what you say, looking at sort of small sensors, a work package looking at sort of integrating quite small sensors together. So things like maybe some local radar, some camera sensing, that kind of thing. So very local kind of sensing. So GPS will get you there, but it won't get you to land because it's not accurate enough. So you need to have this local perception, be it some kind of radar, laser scanning, or sort of other camera things. I mean, cameras are preferred now. People have got a lot of advantage these days in terms of cameras, in terms of quality of perception. It's not just necessarily working out, because normally in traditional camera stuff, you work out boundaries of things, so your edge detection. It's actually working out what things are. So we have a whole work stream about semantics of vision. So you look at something, you don't just say, okay, that's hard, that's not hard. You say that's a car, that's a branch, and you work out how far away it is. And so I think ideally vision will be our main modality, but we recognise when we get quite close, especially, we're going to need something that's fast. The vision's never going to be fast enough to be at that very last stage of landing on things.
Yeah, look, there's some really interesting work going on in robotic vision that I've been across, including from some of the companies out here in Australia too. And it is a fascinating area and will be very useful in things like autonomous vehicles as well as autonomous drones. But just going back to this whole perch and repair, how would you imagine that once you're perched on a building or an infrastructure that you want to repair, you then have the ability to do something about it? Would you see little robot manipulator arms attached to these drones, or would they be detachable? What are your visions right now?
Yes, so I think it will be drones with manipulators on that can do things. So I think there's a whole strand of research being called aerial robotics, effectively drones with manipulators on. And that's kind of what we envisage. So you'll be landing on things, then you'll be doing things whilst perched. I mean, some people are looking at work trying to fly and manipulate. But of course, it's just so energy expensive to do that. So I think with energy, you have to land, if you can land. Then you'll be doing things like depositing material potentially. So on things like exposed pipes, you could deposit some material that would be able to seal it. Other things, the best example, but things like light bulbs, where potentially you can change light bulbs by manipulating things and dropping them in. Of course, right now, light bulb or light posts aren't designed for robots to change them, so you couldn't do it right now. But it would be a relatively small modification to change a lamp post to make it that the robot could change a light bulb. So you can imagine that kind of manipulation where you're just putting things in quite simply, depositing things onto structures. And so the whole point here is that we're not trying to do large industrial work. We're trying to get in there quickly, doing things where before damage gets very large. That's the main focus that we're trying to do. So potentially you could deposit a few grams of material onto a pipe, and that could then prevent the pipe from breaking, which would prevent a huge problem in the future. So there's that kind of scale.
So how big do you imagine these drones would be, either in terms of size or mass?
I think all of the drones will be man-portable. So I think that's kind of our scale. So we don't envision anything being bigger than that. For many reasons, for reasons of just being inconvenient to people, for health and safety. We don't want any very large structures or vehicles going into the city. So things you can carry. Some of them potentially quite large things you can carry. And I suppose mass-wise, certainly the drone is probably less than 20 kilograms. That's the regulation we have in the UK anyway for flying vehicles to make it a certain standard to fly. But probably more like 10 kilograms, I would think. So pretty lightweight things really. And ground vehicles equally so. I mean, of course we can design very large ground vehicles that are quite heavy that can drive through. it kind of defeats the point. It's just so disruptive. Even if you imagine like a robot dustbin, it's just so inconvenient. It's driving around by itself in the city, so we don't want that really. So most things we're going to be doing will be from the air, we think. But potentially we might drop some smaller drones or smaller ground vehicles to do some repairs. So you can imagine we've got a particularly difficult thing requiring a lot of manipulation. Maybe we drop a few little ground vehicles that would do something, and then you would pick them up. I think it would be never the case these little ground vehicles will be driving home.
Yeah, so, really what we're talking about are little swarm bots, that may or may not act collectively, but can certainly be programmed to act as a bunch of little helper bees.
Yeah, exactly, yeah.
So I wanted to ask you about the second goal that you have, which is looking at road repairs and in particular potholes. It's the bane of anybody who drives a car in the city and the bane of cities all over the world. And I believe you're calling this perceive and patch. And my brain was just whirling with ways, how might you do this? And one way that I thought would make sense is you have drones, that are flying over and have sensors and are able to pick up conditions on the road. And then you have little robots of different descriptions that would go out and actually do the fixing. So I'm really curious as to what your actual real plans are as opposed to my imagination of what your plans might be.
Yeah, so I think actually this is one that's getting the most attention, I suppose, like you say, because it's a common problem. So we want to stop the problem of potholes. I think in particular we're trying to catch it again early. So we don't really envisage in the short term filling in very large potholes. It's about trying to catch sort of maybe, 10, 15, 20 millimetre across sort of holes. And then if you catch them early, you can then repair them before they become large. So it's kind of it's a virtual circle in many ways. So yes, you need to perceive them first. So perceiving them, it'll be part of the smart city. So we know that people with autonomous cars already can detect potholes, quite large potholes, but they can detect them with their sensors. So at some point, autonomous cars will be automatically reporting potholes. That's all they already can do now for large potholes. So that'll be one thing certainly. We may be fixing other sensors to detect smaller potholes potentially. Likewise, from drones from the sky, you could do a scan flying across. It's energy inefficient, so in the context of a smart city, you wouldn't probably be trolling around with drones. It's more likely you'd be using things like buses, dust carts, or autonomous vehicles to kind of give you information about what's going on. But once you've found the problem, then you would be using things like, probably drones to come down and depositing fairly small amounts of material to repair things. Or alternatively, you could even do things like microwaves, so they can fire microwaves off, and if it's a very small thing, it can actually melt that and kind of reseal it. So there are several ways of doing this.
Oh wait, so from the sky, you'd fire off a microwave and seal something on the road?
Well, you don't have to land, so you will be close to it. And of course, that kind of energy will be dangerous to people and things, you have to make sure.
Yeah, you don't want to fire at a person walking by.
No. Yeah, so that kind of thing, the activation of microwaves, heat, that kind of thing to try and reseal when it's at a very early stage. The key thing here is you must be early. Once it's gone past that stage, you've got a massive hole. Really, the only way to fix it is to dig it out and do what to do right now and do quite a large industrial works. But hopefully, by fixing the ones that are starting to emerge, and then the program of repairs from other people can catch up, and then at some point we'll have this vision of no problem with potholes.
Yeah, I've also thought that another way that you could potentially address it is with a 3D printer on a robot. Have you given any thought to that kind of activity?
Yes, so we do actually lots of printing with robots already. So we have thought about doing that printing. So the reason you do that is that quite often pothole fixes fail because they don't fit a hole very well. So you have a mismatch of both the side and also the shape. So when you go over it with cars, it comes off. So if you can 3D print, you can 3D print effectively with different kinds of materials, and different kinds of stiffness. If you can do that, we know we already can print with different kinds of stiffness. If you do that, then potentially they'll have a much better chance of surviving. So you do some tests, you work out how stiff the material is, get it very precisely, you deposit the material to have the kind of layers of stiffness, and that's when I think hopefully it'll be more reliable. So it's not really a question of printing to fill a hole, more that the properties of the material you're depositing are digitally controlled to make it match the surface, therefore it won't kind of vibrate out when you drive across it.
Right, because of course on a road there's lots of vibration every time a vehicle goes past or across and so on and so forth. So
just in materials that make them fall out.
Yeah. With respect to driverless vehicles or buses or any other city infrastructure reporting, the sensing or emergence of potholes, are you working with collaborators in that space, or is that still something for future research?
So I think it was something that we've got in the background. So we're not actively working on it because I think that the people who are doing that kind of work are very much focused on getting the cars to drive.
Yeah.
And we know that at some point we'll collaborate. No doubt, probably in a few years' time, when we've got our robots all working well and autonomous cars are slightly more advanced, then to use that data to try and work out with that. Effectively, all they're going to be doing to us is telling us the location of them. So if we know where they are, then it's automatically to go in.
Right. Yeah, and it solves the problem of constantly having to scan, hundreds and hundreds or thousands of kilometers of road space for potential problems.
Energy, and it's things that are going across anyway. You'd use the data from them. So I think the project we have is very much embedded in the smart city, because the smart city, as it's envisaged right now, is collecting data, doing some analysis, and giving it back to people. We envision extending that, so rather than just going to people, we can also use that information to autonomously act through robots. So the smart city is very much a core part of it, and then the robots are an add-on.
Right. Yeah, so the robots are in effect the controllers that are able to make the environment change after the sensors figure out that something's going on. Yeah. So the last mode that I've read about your project is something that you call fire and forget, where ostensibly it's about launching robots into utility pipes and having them live there and report back, pretty much forever. And I can see there'd be a lot of challenges with trying to do that, certainly size of the robot, power for the robot, communications. Tell me a little bit about your ideas there.
Yeah, so we're doing all the work at the moment on sort of pipe inspection robots. People have asked me, okay, what's going to be the biggest short-term impact for robots? And I kind of imagine perhaps people in the house cooking and things like that. But to me, I think that the biggest real-world impact, or the soonest real-world impact, will be from utility pipe robots, because the impact of them failing is just enormous. You lose the flow of fluids, you lose your water, your gas, you dig up roads, you have massive traffic jams because of it. So it's because it's in pipes, it's mostly bounded. So that means that you can't really affect people that much in terms of you can't hit people. So I think it's one application that's going to make a huge impact. Yeah, we're doing a lot of work on this. So inspecting pipes, and then automatically repairing pipes. So when you find a problem, depositing material, or in some way doing something to make it so it's repaired. So we're already doing that already. One thing we want to extend to this project is to make them, they can actually last for a long time in the ground. So, of course, the insertion and the extraction is a big problem with these robots. It takes a lot of time and a lot of effort. So ideally they've been there for extended periods, 1 or 2 years, constantly underground, constantly scanning, not doing it very quickly, because the pipes, of course, hopefully don't fail that fast. So once you've done a section, it's pretty much okay for a while. But just going around, maintaining the network. But like you say, you've got problems then of energy is one big thing. So how do you keep it going? So you either modify the environment, so you can put in sort of inductive charging nodes. Remember, it's like wireless inducting charging on phones. You can do it on phones, you can do it on robots. So you can have things in the ground but not in the pipes to charge the robots. We're also looking at taking energy from the flow of fluid. So if you've got liquid flowing past you, you can capture that, of course, by turbines, other kind of things. And of course, communication is a massive problem. So most liquids don't like communication. It's very hard to communicate through them. So do you dock and communicate? I think that's most likely. So you have these kind of nodes which are charging and communication nodes. So you'll dock to charge. At the same time, you'll upload information which has been captured perhaps over the last week, and then it'll go from there to the outside world and be captured. Because they are autonomous robots, we don't need to know what they're doing all the time. So potentially they can be down there scanning, repairing. We just need to know when they've done the job, how good was it, where it was. So we've got a log of what's happened.
Right. So it could be a communication system that's basically like a store and transmit type of system, like we used to have in the old days instead of real time in the cloud.
Absolutely. We can transmit, so we can do certain things with certain frequencies to transmit through, for example, through gas and through water, because high pressure gas is getting towards a liquid fluid state, and water, of course, is liquid. So there are some ways of transmitting through it, but it's tough and it requires lots of big equipment to do that. So potentially you could try and transmit from that liquid, but it's a much cheaper, more effective way to go and just dock somewhere. So if you can do that, you would do that. So the program of repairs over the next 20 years, for example, when they remove pipe sections, they put them back in again. They just add these little nodes that can be then used to recharge and to collect data. And over time, then you can go and expand the network and make it autonomous.
Well, you and your team have already designed borehole robots that go into utility pipes. What are they doing, and how might they be developed in the future towards this smart city vision?
Yeah, so we have obviously the pipe robots we mentioned previously about going into borehole pipe. We also have what we call borehole robots. These are things that we are doing that can be deployed through drilled structures. So when you've got for example, if you have a building collapse and search and rescue, you can drill through into the structure, and you can insert a robot that can unfold and then can explore the other side. So the key thing about these is that they are quite small. They can get in small gaps. So there are some structures around the city, of course, that are quite small to get into. So we can use this kind of technology to get in through small holes, through drain pipes and other things, into bigger spaces. And then when you're on the other side, you can then unfold and deploy. That's using the analogy of kind of a small kid's toy. So if you drill a hole, you can imagine putting a small kid's car through. On the other side, it just couldn't do anything because it's so small, it has no capability. But what you want is something that goes through a small hole. Once it's through the small hole, it becomes big and capable. So we have these unfolding robots that kind of go from a straight line to being this kind of more advanced robot.
Yeah, I'm sort of picturing origami robots as well, or again, going back to swarm bots, multiple tiny robots that individually can go through these little holes, but then can attach to each other and become one larger robot if they're designed that way.
Yeah, so we have origami robots. They're obviously more fundamental research, but they're basically like sheets of paper that can fold up. We have more conventional powered things that come apart. And we're also looking at reconfigurable robots. So these are fundamental building blocks that can assemble and detach. Like you say, so you can post a load of these things through, and they can assemble themselves, kind of like some sort of crazy transformer thing.
Yeah.
So they're mostly futuristic things. They're not the sort of the stuff we have, which is more conventional in terms of folding, is most ready to go into market, if you like. But the other stuff is still in the background.
Do you have any prototypes that you're able to show us at this stage? I know you don't have them with you physically right at this moment, but are there things that you might be able to point us to?
Yeah, I've got some sort of more conventional things in terms of folding things. That's not there. The other stuff is more conceptual, and so we're working on that, maybe commercialising potentially. But certainly for the more conventional folding stuff is out there on the website.
Oh, that sounds cool. We'll definitely check out and put some links to that. And one last thing before we finish up today, and it's another really cool project that you and your team have been involved with, and that is exploring the pyramids in Egypt. I know that you designed some very special robots to be able to go into places that people haven't seen for thousands and thousands of years. What kind of robots did you use for that?
Yes, so in the particular period we're looking at, there are these so-called air shafts, which are quite small square shafts. They're 200 by 200 millimetre in sort of cross-section. And they go from the very centre of the pyramid towards the outer casing, start off horizontal, and then go at an angle of 40 degrees. So you need a robot that's quite small that can enter these shafts, but also climb up these shafts, of course carrying sensors, and also in this case carrying a drill, because these air shafts are so-called air shafts, don't leave the casing. It's about 10-15 metres of a question mark. It could be massive loads of stone, or it could be hidden chambers. So that's what we're trying to understand. So the robot we built, very customised robot, we're able to climb up these shafts, carrying these tools, and explore and try and find out what the purpose of these shafts were. So it's a very challenging project. Because you are climbing, it's really an aerospace type problem, because any bit of mass you add to the robot requires more force to climb, requires bigger motors, so it's sort of a vicious circle. So by making it incredibly light, you actually remove lots of constraints. So we use up the 3D printing, so we have a metal chassis which we do all the mechanical work with. But beyond that, everything else is 3D printed to make it lightweight and small as possible. And we were out there about 3 or 4 years ago now, and we had some great results, found some really great things. So it's a good project.
So is that project over now, or are you still doing some exploring?
So we have robots. We're waiting to get access back to Egypt. That's what we're waiting for. Hopefully we'll get it fairly soon. But we have some great robots that can do some even more advanced things. So we just need to get access back to get an answer. So we found some writing that's hidden for thousands of years, which is an amazing result. There are definitely more things we can find. we just need to get back there.
Oh, that will be so cool once you get that permission. I want to thank you so much, Rob, for getting up early to chat with me about your self-repairing cities and all the interesting robots that you and your team are working on. So thank you very much.
Great pleasure. Thank you.